Welcome to the Misfits Unmuted. It's a podcast where we talk about anything we think people might want to hear. We mostly focus around Mist, Wi-Fi, networks technology, and occasional wire or two. So each episode will have a different member of the Misfits group, which, if you do not know, is a group of ambassadors or evangelists who all have kind of a shared interest in Juniper Mist. Each topic will be whatever they want to talk about. So we find people, they have an idea, we put a podcast on. I am one of your co-hosts. My name is Robert Boardman. I'm a consulting engineer and a technologist at Juniper Mist, and my co-host is Stephen Cooper.
Thanks, Rob. Great to be here. I'm also a consulting engineer at Juniper Mist. I've known both Rob and Dan for quite a long time, so this is going to be quite a fun episode, I think. And today we have from Hamina Wireless, Dan Jones joining us. So thank you for coming along, Dan. Could you just give us a quick introduction about yourself, how you became a Misfit, and what do you do at Hamina Wireless?
Yeah, sure. Well, first of all, thanks for having me on. Honoured to be your kind of first guest that you have. So my name is Dan Jones. I'm a technologist at Hamina Wireless. I don't know what technologist is either, so don't worry about it. I often say that, like Beck had like the hype man that would be on stage with them. So they'd all be like actually playing instruments and then they'd just have this guy that just jumped around on stage with a tambourine. That's me. That's what I do for Hamina. So
you're a trained monkey right here.
Hey?
Trained monkey.
Trained monkey. Yeah, that's good. I think that's all right. And Hamina is like a wireless design, troubleshooting, validation tool, right? So we make tools and software where you can design a Wi-Fi network, not just Wi-Fi but wireless, and then plan it out, test things, troubleshoot stuff, things like that. And then how I guess I got involved in the Misfits is I was asked to join because I'm an oddball, and it looks like everyone that's invited to that group is a bit of an oddball. So I enjoy my time there with them. Yeah.
So, since you're a misfit, what are we going to talk about today?
So you guys kind of said like, what types of things might you want to talk about? And so I wanted to talk to you guys about surveys. And what are they for? How do we use them? What do we think the kind of future of them might be, right? And I've obviously got like an insight into that, being someone that designs a tool that you use to do surveys. But I think hopefully it will kind of help like you guys and also kind of people that might be listening to this to think about surveys a bit differently, right? That was kind of what I wanted to talk about.
So you're coming in to tell us AI does everything. Surveys are dead.
Yeah,
we don't need them.
Yeah.
Just kind of like 2.4's dead, surveys are dead.
You don't need a tool like Hamina. Just use AI. Yeah.
Red solo cups are making a comeback.
Exactly.
Just do some vibe coding. You can make your own 3D planner.
Yeah. Exactly that. Yeah. So I think what I wanted to talk about, like to go a bit deeper into it, was like, we've always had this this idea of doing a server, right, where you walk around with USB dongles attached to your laptop, or a dedicated survey device where you walk around and you kind of then heat map kind of what the devices can hear, right? And it was always seen as like this is what your network is doing, when it's not really. It's like, this is what your network was doing when we happen to be walking around, right? And so then kind of thinking about how we can change that and think about surveys differently. And when I say surveys, I'm talking about the walking around and measuring the actual kind of Wi-Fi, not the design part, right?
So you're saying you don't want to walk around carrying an AP on a stick anymore, right?
Yeah, the AP on a stick thing is a real thing that I think we should talk about too.
We're gonna cause some splits in opinions today, I think.
I think we might ruffle a few feathers, yeah.
Awesome. So, I mean, on that note, Dan, like, whether it's talking about surveys or even deployment planning, one of the big things that comes up, and especially the pitfalls that a lot of people fall into, and like you said, that measurement in a single point of time, or even not getting the right information into your design and deployment, and it throws off things when it comes to surveys. So attenuation, that side of things is quite an interesting topic. So what sort of challenges do people usually face in that phase? And like what sort of examples can you give that, can or cannot be solved by a tool like Hamina?
Yeah, so like there's a few things, right? So I think like the first thing, like you're saying, when you're doing the design, like, I can draw out a brick wall, but how do I know how thick that brick wall is? How do I know how much attenuation actually happens in that particular thing? Especially when you're like we are now, right? We're all working in the European market where you can have a 400-year-old building where you think it's solid brick this thick, all the way through, and then you find out that no, that was plastered in, 3 weeks ago by Jeff, and actually there's like zero attenuation in that space, right? So, so it's like there's a couple of parts to it, right? So initially in the design phase, it was always like you're guessing off the thickness of the line on the floor plan, right? What's this made of? What's this kind of done? Then you might, if you were kind of being really thorough, you might go to a site, set up like an AP, measure the actual attenuation of, say, each wall or each type of wall, Rob.
Yeah.
So you might do that, right? But again, the problem with type of wall could be, well, you think it's a concrete wall, but actually it's a dry wall, right? And then you kind of had this other thing where you could, okay, well, what we'll do is we'll use the survey data and we'll calibrate the walls that we've drawn on, but you still had to draw in the right type of wall, right? So if you put a brick wall and it wasn't a brick wall, it was a brick wall for 2/3 of it, and 1/3 was drywall, it would just average that out for you, right? And actually then just completely mess the thing up. Yeah. So what in terms of like attenuation, there's the wall side of things, but there's also things like reflections, diffraction, scattering, all these kind of reflections and all this kind of stuff that actually
10 BB sacks of water walking around.
Yeah, exactly. Yeah.
And everything else aside from walls, it's not just walls. There's elevator shafts, there's fire exit stairwells, there's warehouse racking. We could go
UV
on for
coating
ages.
on glass.
To be honest, it makes it sound like what you're saying is we need more AP on a stick surveying.
Right. Well, so this was the other problem, right? So previously, before I was at Hamina, when I was doing, systems integrating, value-added reseller stuff, we had to have like one of every AP that we ever sold, right? Which was just an absolute nightmare because you've got this massive case of all these different APs because you had to use the exact AP model you were going to use to kind of go to site and validate, if I put an AP here, how far out is that cell going to be? How far out am I going to hear the signal? And you had to use the right AP because every AP has these different antenna patterns, right? So it became this absolute nightmare. And so, this is kind of how we used to do kind of surveys. This is what surveys used to be, whether it was like a wall attenuation survey or it was an AP on a stick survey.
I would challenge you that it's today how we do surveys. Unfortunately, that is the de facto way of doing survey. I'm thinking of using this AP, go get this AP, and then go survey with this AP, and call somebody to fix it after it's done.
And so, how much better would it be if rather than having to use a specific AP, we could use anything, right? We could use the existing APs that are in a space. We could use, a mobile hotspot or something like that. And all we're looking at is how the signal is affected, right? Whether it's going through a wall, whether it's going through a piece of machinery, whether it's, whatever it is, right? If we just measure everywhere what the signal is, where it's come from, draw lines out from the kind of source that this Wi-Fi signal is coming from, then we can build up this amazing kind of 3D map, right, of attenuation. And then we could just put that on top of whatever floor plan.
So it's almost like you're saying less AP model design and more attenuation design. You're actually designing attenuation. You're not actually designing for an
because that's what we are doing, right? Mm-hmm. When we draw in the walls, when we draw in the desks or the wardrobes and things like that we're trying to get through the shelving. like we're not actually drawing the shelving because there's shelving there. What we're drawing is this is how much it's going to attenuate. So let's just measure how much it attenuates.
So you're saying actually start paying attention to the thing we've always cared about, but never really paid attention to?
Yeah, exactly that, right? So the idea being, right, that now what we do with this survey is rather than telling you, and we can still tell you this is what your network looked like at that moment in time, we can still give you that, right? But now what it's about is actually more about creating like an attenuation model, right? So we're building out an attenuation model. We're applying that to a floor plan. And now you can draw the walls if you want to, so it looks pretty, but we're not using that, right? We're not using those kind of values. We're actually taking the real world data and then showing that. Yeah. And then we can use it for other things, right? So then we can start using it for things like, instead of doing an AP on a stick survey, now that we've got this attenuation map over the floor plan, I can put whatever AP model I want in there. I can show you the difference between, you know, an AP45 and an AP47. I can show you the difference between an AP47 and an AP47D, right, with the directional antenna and all this kind of stuff. So, and now we're working from real world data. So things like the scattering, things like reflections, they all show up because we're measuring the way that the RF actually kind of worked in that space.
Yeah.
It's kind of an interesting idea. When I was way back when Top had a survey, I'll refrain to let the guy's name put it public. He might not want it public. But he used to say you take a measurement and then you adjust the walls to match your measurement.
Yeah.
So you're basically, you're not using, remember, every design program, that number was a number somebody said sounded really good at that point in time. They might have measured, they might have not, or they might have just copied somebody else's number and said, why not?
And I think for a while that became the de facto approach because it was treated as good enough.
Yep.
Because of the balance of trying to save time and costs with doing that. And so we always say, you know, garbage in, garbage out when it comes to the designs. So, you know, we've seen our fair share of bad designs that have been influenced by these sorts of, you know, shortcuts, if you want to call them that way, or corner cutting.
Yeah.
Just because you don't have the right information.
To the design software's benefit, you have to pick a number. You can't.
Yeah, exactly.
You're not a construction company. You're not going to be like, well, today the drywall was a little dense when I took it, or you know what I mean. Somebody decided to put metal beams every 10 centimeters instead of whatever, So you have to pick a number. So
yeah.
It's a starting point. It's not ever supposed to. I think people have kind of grown accustomed to drywall's a 3 dB loss.
Mm-hmm. Yep.
And in which country, right?
Yeah.
Because what construction company? Because I've worked in places where what's down on the architect's drawings as a plasterboard, as we would say in the UK, wall. It's like, plasterboard, but there are 4 boards, right? Or
that's the thing. What's the insulation in the walls? Is there extra soundproofing or thermal insulation? So
you probably have seen it. Like I've done sound studios where they come in and it's just a wall this big. We're doing a meter wall. And it's just lined with drywall. It is 100% drywall to eat sound, and that. It attenuates.
Yeah. Well, especially because like a lot of those building materials, and again, like you go back to some of these older buildings in Europe, and you've got like limestone walls or whatever, right? And they hold moisture like there is no tomorrow, right?
Yeah.
Whereas you can go to like a concrete thingy, and again, depending on how they've built the concrete, you can have anything from like 5 dB up to like 25 dB, right? It's just impossible for you to know just looking at a floor plan what that's going to be.
Mm-hmm.
So, in terms of these kind of like, Hamina has this thing where you upload a floor plan and we'll automatically build walls for you, right? And we'll see when there's like an elevator, we'll put thicker walls around the elevator. We'll see doors, we'll put different things in for doors. We've got new models that are kind of coming out that are going to have things like, windows, different types of wall types, all this kind of stuff, right? So that's all there, and that gets you to a certain point, like you were saying before, right?
Gets you to a better point.
A number.
Yeah.
Yeah, exactly.
Yeah. It's a starting point. It gets you to where you can go, okay, you gets the monotony out of it, basically, which is, to be fair, something that I think I will say this and get crucified for it, why we have become lazy in design is because of the monotony of having to draw walls and having to do all of these things, and it's just like we've gotten to the good enough.
Yeah, exactly. Yeah, and we'll give ourselves some wiggle room in the design, right? We'll turn down the radios a bit so RM can do its thing, and all that kind of stuff.
Give us a nice 3 to 6 dB gap. We're fine.
Yeah, and you're gonna still have to have that, right? Because you'll have greenfield sites where you can't go and measure the wall because there isn't a wall yet, right? And you still have to make the design and all that kind of stuff. So that stuff isn't going away. But then it's about, okay, well, what can we do now? Like, it always used to be you'd buy this kind of survey kit, right? And you'd get to use it, once a year at a site. It's like, geez, that's crazy, right?
Dust it off, upgrade the firmware, make sure the battery's charged.
Exactly. Make sure it actually charges this time, all that kind of stuff. Yeah. And it's like, well, actually, like, what if we could take that survey data that we had, that kind of one and done kind of thing, and then apply it to now, say, like a live model where, especially with Juniper, right, we can use the APIs that you've got and we can pull down the data that we've got, right? So we know the make and model of the AP, right? We know how it's been installed because we have all that information that's being streamed from the dashboard, right? So now we can take an AP with, say, 3 radios in it, a 2.4, a 5, and a 6. We can see what dB power we're kind of sending out from the 5 gigahertz radio, and we can use that attenuation that we've got, that attenuation map, and just apply it to where that AP is on the design, right? So now we've got a survey that's live all the time because we know how RF moves through the building, and now we can just apply the real-time live power that's being put through the radio, and now we can see, right, okay, this is your blast radius of this cell size. This is how the RF is going to move through that space. And so now you take this kind of one and done, because it's now an attenuation model. Now you can go and survey that site whenever you want, because we just load up, in the tool what you're using right now from the dashboard, and we can visualize it, we can see it.
You can combine it together. Yeah.
You can also, during the busiest times of the day when you actually want to know what the attenuation model is, you don't have to be that goofy guy in a vest with a bunch of people around you going,
right. Yeah.
Excuse me. Surveying.
Yeah.
The other nice thing about that is it removes kind of the need to draw walls, because if I already know the attenuation, the walls then aren't as important.
They just become, hey, doesn't that 3D plan look pretty, right?
They're just more visual references for us on the design.
Yeah, exactly. Yeah. Which is okay.
Yeah.
But like, what you actually want is really accurate data, right? You don't want an averaged out, all of the walls have been averaged to this number. What you want is, no, if I've put an RF source in this location, what impact is that going to have in the space? Because then what you get to see are things like, your co-channel contention that you have, you can see the blast radius of that, right? When you've got just your APs in like a table in a dashboard, you can see that you might have 2 or 3 APs on the same channel, and you might think, oh no, that's going to be a problem. But when you actually then put that onto a floor plan where you've got this attenuation map on top, you can see, right, yeah, they are on the same channel, but they can't hear each other. There's no blast radius of where that's happening. That's why, Marvis, the Mist RRM, has decided to use these channels, because actually they can't hear each other. They're not impacting each other. All that kind of stuff.
Sorry, this just makes me happy. It's like, this is a conversation over a beer that we've had about a half a dozen times with a half a dozen different people, and we're just like, by the end of it, they're like, oh, Yeah, that does kind of make sense.
Well, and not only that, right? But then you can start to, once you've got that attenuation model, you can then bring that back into your design. So you've got your survey, you've got your live of what things happening, but then it's like, okay, say you're having a roaming issue. CEO comes out of their office, they're walking to the boardroom. There's some roaming issue that's happening, right? Well, now we can take that attenuation model, put it back into the simulation, and go, right, okay, well, what about if we turn this AP down and we force the AP to be turned down? Great. Now I can see the impact of that. I can see when the CEO's iPhone is going to roam, and then you can actually start building in and designing proper roaming into your designs, and seeing the impact that changing kind of your RF templates and things like that are going to have too.
You mean when you struggle roaming, you just don't add another AP? I thought we just add another AP. Fine.
Just turn them all up to 11. Yeah, just more APs up to 11.
More power. It's nice because it's a good way of actually you can show that, hey, you might need to turn power down. I think people sometimes forget when you have a bad experience, a lot of times the power needs to go down. It doesn't need to go up.
Yeah.
And also, like, again, like thinking back to like when I was doing stuff previously, right, I would have some quite challenging environments that I'd have to design for, right? So you've got like big open spaces and things like that, right, where can I have an AP on the ceiling? Well, yes, I can, but even if I have an Omni AP on the ceiling and I turn it right down, it's still going to travel for miles, right? So then again, it's like if you've got this actual RF model, you can show the difference between, hey, here's an Omni AP, here's a directional AP, right? And the reason why we're suggesting you should use an AP47D in this place is because of the difference. Even if I turn the AP right down when it's Omni, it's still just going to spread and spread and spread.
Yeah.
Right? Whereas if now we put some directionals in, we can control that a lot better.
Yeah, I think the large public venue guys have been doing this for a while. I mean, the really good ones have been focusing on attenuation because that's their entire. They need attenuation, so it's a good thought that we change our mindset from a coverage-based survey to an attenuation-based survey. We need to know what the attenuation is, not so much what the coverage is, because coverage is easy.
Yeah,
it's getting it where you want it. It's important.
Yeah, and again, the problem with your coverage survey is that it's only telling you the coverage where it was when you happen to survey it at that one time, right? Whereas now your survey is something that's valuable, for weeks and weeks and weeks afterwards, right? And then when it comes to like, oh, we need to go and resurvey, it's like, well, have the walls moved? No. Great. Has any of the furniture moved? No. Well, then we don't need to survey. And on the converse of that, hey, you want to go and do like a whole redesign of the space? Not a problem. We'll just come and walk around. We won't interrupt anyone. We can just walk around, update our attenuation model, and then apply that afterwards.
Based on the existing Wi-Fi that's already there.
Exactly that. Yeah.
That's like, especially like you were talking about it with the Mist side of the house where we're doing AP to AP coverage. It's a good point now where we're able to do living and breathing attenuation maps essentially. Say you're moving from, I want to go from a 45 to Wi-Fi 7 and do 47. AP to AP has changed. We do this whole, a 1-for-1 replacement, which is as the cringes. Sometimes it works, sometimes it doesn't, most times it doesn't. But hey,
at least if
it gives you that. It gives you that ability to look and see, can I do a 1-for-1?
Yeah, exactly that. Yeah, so even if you can't get to a place to do a physical walk around survey with a survey device, like again, because you guys give us the API endpoint, right? We can just go, well, okay, we know where your APs are because you've put them on the map where you've installed them, or your installer has at least. At the very least, what we can do is go and hear how that one AP hears all the other APs, and we can at least give you an attenuation heat map of that, right? And then use that at least to start with. And okay, that's only going to work where you've got, like an office space. It's not going to work in somewhere like a warehouse or something like that, right? But in like an office space, which, let's be honest, is like 90% of Wi-Fi deployments anyway, right?
Yeah.
You're going to get enough that, I actually won like an RFP previously selling Juniper based on the fact that what we said was, hey, we'll go and like physically walk around, survey your top 3 offices, right? So New York, London, and Sydney, and the other like 400 offices or whatever it was they had. We were like, we're just going to do an AP to AP survey. So we're going to take the information via the API from the dashboard. We're going to visualize it in Hamina, and we're going to show you. And I think out of those like 400 offices, we had like 2 or something that we had to go back and fill in like a coverage hole. Where the wall material was different than what we thought, right? But imagine that, right? We've gone from having to go and physically survey 400 sites to now only having to go and survey like 5.
You both mentioned something earlier, separately but related, and it just made me think. So, talking about the live environment surveys from the AP to AP data, and Rob, you mentioned, question, have the walls moved? Dan, you just talked about doing warehouses and where this might not be applicable. I think it actually would be applicable, because the number of times I've designed warehouses or distribution centers in that particular format, and a lot of these large distribution centers, their formats will change. They'll rearrange the racks and how they're laid out, and especially when you have varying levels of stock, you could do your design, you could do AP on a stick for all you want to, and deploy everything exactly as it's been designed to. But if everything changes around, in the past, you would have to then go through and resurvey that entire huge environment, which takes hours, if not days.
Oh, yeah,
This integration would actually allow you to do a spot check and go, what, things have changed. We can see the attenuation model has changed without having to step foot on the site and justify whether there is a need to do some further on-site analysis.
Yeah, and I think that's the big point. You're right, Stephen, is like it justifies having to do that truck roll. And like that for me is a big thing, right? Because you didn't have a choice before. It was, we have to go to site just to see if something's gone wrong, right? Or something's changed. Whereas at least now you've got some sort of indication. Because even if you're able to pull up the client view within Hamina, right, you can see, okay, what's that client's health right now? Because even if something has changed, are they working all right? Yeah, they are. Perfect. Okay, great. Well, then we don't have to go and do anything. Whereas if you see all of a sudden, okay, we notice whenever anyone walks down this aisle, all of a sudden, their signal tanks, they have a terrible experience. It's like you can watch that happening in real time, and then you go, okay, cool, we definitely need to go to site and figure out what's going on here. So even just being able to do that is a massive improvement, I think.
Yeah. I'm just having nightmares of warehouses.
Sorry, Rob. PTSD.
Yeah, I'm having like flashbacks. It's like nothing like a warehouse design that comes in and goes, yeah, and then you walk in. Oh yeah, we changed the rack layout today.
So this is a awesome conversation for a podcast, but I think it'd actually be cool if we showed some stuff for those that are actually going to have a look at this later on YouTube or whatever. And for those that are maybe listening on their commute or their drive, just a heads up that there will be some useful stuff to show. Dan, did you want to walk us through a screen share of anything?
So let me just quickly show you then somewhere that we've surveyed, right? So this is a survey. So we're in Hamina. We've done a survey, right? So you can see here when we click on APs, we can see how the attenuation works in that space. So yeah, you can kind of come through, see how we've kind of walked around that space. And we've then got the data in here, right? So when I come back to the simulation now, what I can do is I can come into here and I can go to the settings that we have in the top here. And rather than use the walls and objects, I can tell it to come and use the environment learning that we've got from the survey data, right? So now when I start clicking on these APs, I can come in here, pick my AP model. So, let's say we're going to go for the D, and you can see how instantly that kind of shrinks stuff in, and it's a much tighter thing. And then if I go back to the standard 47, it's Omni, you can see how that kind of expands out, right? But like, notice how in the actual design itself, there are no walls where these kind of walls are. So in the actual design, I haven't drawn any of these walls, but you can see as you move the AP around, it's being impacted like there are walls, because we're not using the kind of walls and objects like we always traditionally have, right? What we're saying is no, use the actual attenuation like data that you have, and then build it out from that.
Yeah. And so this might be challenging for those listening only, but again, a good thing to come back to watch when you have the time to, if you're not watching in the video side of things. But essentially what Dan's showing is, because we know the AP placements, we know the scale of the floor plan, we know the position of the APs relative to each other, and all of the measurements that the APs are doing, AP to AP, and sending that data up to the Mist cloud. We know what the free space path loss is then between each of those APs as we've measured it live in the environment. So that's why we don't need the walls. And as Dan is moving the APs through the environment, the coverage changes, as you would expect if there were drawn walls in there. But without the walls being placed in there manually, it's automatically got that attenuation model there, and shows it in a live view. It's pretty awesome.
Yeah, so let me show you our office, right? Because we've got Juniper in our office. So again, we've got the survey data here, right? So we can see that we've got the survey data. If I come to the live view, so what this is doing now is it's making API calls to Mist, and it's kind of saying, hey, give me all the information that I need, right? So if I click down on here again and I go to these global settings, what you have now for our prediction mode, before we were using the kind of environment learning, the survey data. Well, now for the live prediction mode, I can choose to use the survey data. So if I show you that first, so again, this now is this AP right now with its 14 dBm on the 5 gigahertz radio. This is the kind of spread of that AP as we saw it from the survey data, right? Yeah. If I go into here, right, if we didn't have any survey data, say, it was a remote deployment, we couldn't get anyone to go out on site to do a survey, the next best thing would be to come and use the AP to AP data. Now, obviously, the APs are going to hear each other louder than a kind of measurement device or whatever, because they've got bigger antennas, all that kind of stuff. But what it will do, and you can see here, it's pretty similar considering how much louder these APs can hear. But what you can see is effectively the APs are being impacted. This environment learning model is being impacted by how loud the other APs can hear this particular AP. And again, we're pulling all of that through via the API. It kind of works out.
And I mean, you did make a good point to the APs hearing each other louder, but at this point in time, we're not judging coverage, we're judging attenuation.
Yes, exactly that.
And exactly that. So you become less reliant on sensitivity of data, because because people are always worried about what my client is. How's my client going to hear this? You're just making attenuation.
Yeah.
It so again, removes that what the device is completely out of the conversation at that point in time, because you could just switch APs at that point in time. You'd still have that same attenuation.
Exactly, yeah. So I can come in now, and I've changed this one to just use the attenuation that we got from AP to AP. And you can see as I move it around this space, you can see the AP kind of, is changing. It's changing shape as you move things around the space.
And so for everybody here who is listening or watching that might not be using Juniper Mist yet, you all should be, but that's, not everybody has, made that jump yet. You'll get there. But for those of you who haven't, this still means it's easy, something that you can actually do, because yes, you'll start to take a survey, but you could ship a device off to a random person, say, open up this app and walk around. And again, it's still gathering. What you're doing is you're taking, I hate to say the expertise, but you are taking the monotony out of it.
Yeah. And
getting much better data, because you're no longer going, crap, that guy didn't walk into that office. He didn't stop at the back window. I don't know my cell edge. You're now going, I have a general understanding of the attenuation. I have a place where I can start now.
Yeah. Yeah, and as has always been the case, right? It's about getting the best data you can. Now, sometimes you can't always do a really thorough survey of every single space, but we can combine all of those things and give you the best data that you can get, and then you can make, the decision based off of that.
So it's almost like AP to AP being more sensitive, higher quality radios and antennas would probably give you a better attenuation loss than some random device you carry on your hip that you don't know which way you're doing to.
Yep.
Not saying that that's a good thing.
Well, it's an additional data source, and it's a very accurate data source at that. That's
Exactly.
what's cool. So,
Yeah.
and I think that was one key thing we touched on earlier, but also, Rob and I and the rest of the team get this question a lot, just saying, well, if you have all this data in Mist of all this, client-side telemetry and how the client views the world once you've deployed Mist APs and you've got coverage and capacity metrics, do I need to do surveys? Why don't I just put APs everywhere and Mist will just tell me where I do or don't have problems? And we're like, hold on a minute. Can you dive into that?
Physics.
Yeah.
It's like,
Same thing
there's
this as well, Dan. It's like, this doesn't replace the need for design and or surveys. This is just another piece of the engineer's toolkit to make better Wi-Fi, essentially.
Well,
Yeah.
and just from a commercial standpoint, right? Like, you're going to put up an extra 10 APs you don't need?
yeah.
Like,
I've seen it happen.
never-
Unfortunately, I've seen it happen.
Yeah, I've never understood that. Well, just throw up 10 APs, we'll be fine. You're like,
We'll just turn some off, and it's like,
tell you
why?
need 5 less and save you a bunch of money.
right,
Yeah,
exactly. Yeah.
So, yeah,
And
it's...
this is an attenuation and design conversation, but probably the topic for another time is about the whole capacity side of things. You mentioned it earlier, right? People just like, let's just solve problems with roaming and throw in more APs. People try to solve problems with capacity and just throw in more APs.
It is
doesn't
a
help.
shockingly scary thing how often you get an email that says, "Hi, I'm having a roaming or capacity issue. I need to, 20%, 10%, an extra AP." You're like, "Whoa, no, that's definitely not what you need. You need to understand what's going on first, and this can help kind of say." To the opposite, the lack of attenuation, where you come in and how many times have somebody thrown in, well, I need 3,000 people, here's 40 Omni APs, and you have 2 APs at the front of the room that are just soaking everybody. And
Yeah.
you can use this kind of thing to tell you where you're not attenuating.
Yeah, and like the amount of times that I've kind of gone into a space, and it's not that they've got the wrong config, it's not that they've got the wrong AP, it's not that they've got bad drivers, all this kind. It's that they've got one AP right next to where everyone walks through the lift. They all connect to that one AP, and then everyone has a terrible time.
Everyone sticks to it. Yeah.
They go, my experience sucks. Your computer is really happy on the Wi-Fi right now. It's
Exactly.
next 60s. It's got a great MCS rate. It's not my fault that you're that side of the room and everybody else is connected here too.
But it happens all the time, right? Massively.
Yeah. Oh, that's another conversation. That's a capacity conversation that we can, because we'll be on this podcast for another hour. We might just schedule up the next episode right now, just cut and...
Just crack on again.
I've got a bit of a leading question for you, Dan, which is going to give you an opportunity to say what else is coming up for Hamina Wireless. We've seen some awesome stuff. What you've demonstrated today on the screen share for the people watching the video, you were showing the 3D models of the floor plans, which is also really useful when looking at designs and surveys. What else is coming or is very close to coming in terms of, we've talked about environment learning on a floor plan basis. What's happening from a 3D space perspective, and any other cool things that are coming?
We've got lots of cool stuff coming. One thing I can tell you about, let's start there. We will have full 3D building view, right, in 3D. So that's great for, yes, you've got an atrium that goes right through your building. You want to be able to see the impact of that atrium across all your floors all at the same time. Yeah, we'll show you that stuff. You've got a stadium that's actually 4 or 5 floors worth, right, on the kind of outside of the stadium, and then you want to be able to see that impact in the bowl as well, right, rather than doing a separate bowl design, separate kind of back of house design. That'll all be just in one place. You'll be able to see the impacts of everything.
That'll be nice.
So
That'll be nice.
I think that's going to make a massive difference to a lot of designs.
My dreams have been answered. Thank you. You were waiting for this to tell me, right? So I can.
Oh sure, yeah. It was all for you, Rob. Oh, absolutely.
I've been begging.
And I think you touched on the client view very briefly in the demo, but also conversation. That is another feature that's pulling everything from the Mist API in terms of the client experience. So having that all in a single building or single a facility or environment like a stadium, to be able to follow a user's experience from all the data that you get from Mist, from all the service level expectations, having that in Hamina and be able to visualize that, that's incredibly powerful.
Multi-floor roaming man, baby.
Yeah, and again, like the whole point of what we're trying to do, right, is visualize these things. So it's not that you don't have roaming analysis already, but your roaming analysis doesn't necessarily tell you, has it gone to the optimal AP or has it gone to an AP that's okay? You know, that type of stuff, right? So it's like you might have designed thinking that a client is going to go from APA to ABB to APC, but actually they go from APA to APC every time, right? And you can now kind of see, oh, okay, why is that? What impact is that having? Yeah, and all that kind of stuff, which is going to be cool.
So I think we've been talking about this, but do you have any final points before we close this out on this kind of last question, which is we've been talking through, is regarding survey data. With the new live view pulling data from live infrastructure, do you think it's relevant to perform on-site surveys nowadays?
Yes, when something in your environment has changed the attenuation. That would be my answer.
It depends.
Well, I think like there's no point in doing so. Again, previously when I had my MSP kind of hat on, right, it was we sold a service of we'll do X number of surveys a year, right? Now it should just be, hey, if anything changes, come and tell us. And we don't even have to go and survey the whole building, right? We just need to survey the bit that's changed. And then we can just put that new bit of data in, apply it to the rest of the data. Because that's another thing that we kind of haven't spoken about, right? You don't have to have an all or nothing with our survey attenuation data. If there's a new part of the office that's been built, just go and survey that bit. If there's a part of the office that's been changed, just go and survey that bit, right? We can lay that on top of what you already had and then update the attenuation model from there. So now, like you say, Goops, when it was like, oh, you know, do I need to go and resurvey this whole warehouse site? No, just go and survey those 3 aisles that have changed, and now you've updated your model.
Yeah, you're taking that survey and just instead of blindly doing it, you're now targeted it. So you're now actually providing a better service to your customer because you're able to actually be more poignant. And there's another conversation to go based on time versus project, where we need to probably all start moving more towards project and less more time, because it's outcomes. It's outcomes, exactly. We're here to make customers happy. We're not here to spend 40 hours trying to make a customer happy walking around.
Wasting time. Yeah, exactly. You know, it might have been that, you know, to walk around a warehouse, it was going to take you 3 days. Great. Well, if only a small section of that's changed and it now takes you an hour, great for everyone, right? Because now that's 3 days that the warehouse doesn't have to slow down or shut down operation while someone's walking around on site.
It's time for you to analyze that data that you got and actually make a better choice and decision instead of saying, crap, I have to do 3 days and now I'm rushed over the next day getting it all done. You could say, get what I did, do this, and you're still using that same amount of time. It's just how that time is being used.
And don't get me started on how long it takes you to make the report. That is definitely a subject for another day.
All right, everyone. Well, I think that's bringing us to a close of a very interesting discussion. So thank you so much for joining us on Misfits Unmuted. And this is our inaugural episode. And thank you so much, Dan, for coming along and having a great conversation with us and showing us some cool things and sharing your insights and your experience. We're going to have some amazing guests in the subsequent episodes, so keep an eye out for the next one that we launch. And for this episode, you'll better catch the recordings on, you know, the usual podcast channels. We'll have the video recording up on YouTube as well, so you can see what Dan was showing us there, and you can catch, you know, Hamina updates on YouTube as well. And for any other information that you want about this topic that we discussed, or any of the future episodes, or even more information about the Misfits, feel free to send an email out to misfits@juniper.net. And we'll provide some additional information in the podcast and video links there as well. So once again, thank you so much, Rob and Dan, for being on here today. And thank you everyone so much for listening. We'll catch you next time.